Dear students, today I am going to teach you the chapter 8 motion. As the name of the chapter is motion, so we will first understand what is motion. Motion is basically the movement of an object. For example, when we are in the bus, we see that the roadside trees appear to be moving backwards. But when we are on the road, then the roadside trees are stationary. So why this happens? There is an important concept to be understood, which is known as the reference point. When we are in the moving bus, then the bus is considered to be reference point to observe the trees. But when we are on the road, then road will be considered as the reference point. So depending upon the reference point, the motion or the position of an object changes. I have highlighted some important lines of this page. Here again it has been said that we describe the location of an object by specifying a reference point. So if any question comes regarding the reference point, then you can make the answer from this section. So here there is an example of what is reference point. Suppose the distance between the school and a railway station is 2 km. Here how we have measured the distance between the school and railway station? We have specified the position of the school with respect to the railway station. So here railway station is our reference point. Now if we change our reference point according to our convenience, then the distance between them will vary. So to describe the position of an object or motion of an object or location of an object, we need to specify a reference point, which is also called as the origin. Again I have highlighted two important lines. Here you can see that the distance and the displacement are used to describe the overall motion of an object. Here distance is used to describe the overall motion of an object. That is, overall motion means how much path it actually covers. But displacement means to locate its final position with reference to its initial position at a given time. Here the final position is this 15 and the initial position is O, that is at 0. So to locate the final position with respect to this initial position, we have taken the concept of displacement. But when we want to understand the distance, then it does not have any initial or final position. It just describes how much distance it has covered, how much path length it covers. Again, another one important thing, that suppose you have started your journey from school, home to school, and then again to home. So the distance will be two times the actual distance between the school and home, but the displacement will be 0, because first of all at the first you have gone from home to school, that is a certain distance, suppose 50 km, and again when you come back from school to home, then it means that it is minus 50. So the total displacement is 0. But the distance will be 50 plus 50 equal to 100, because distance doesn't consider any direction. Another one important topic is uniform motion and non-uniform motion. From the name uniform motion, we can say that something is equal in this type of motion. Now what is this something? We can understand this by an example. Suppose an object is moving along a straight line. It travels 5 meter in the first second, 5 meter more in the next second, 5 meter in the third second, and 5 meter in the fourth second. In this case, the object covers 5 meter in each second. That is, the distance covered by this body in each time interval is 5 meter. That is, the distance is equal, and again the time interval is equal, which is 1 second. So if these two things, that is the distance covered and the time of interval are same, then we can say that the object is having an uniform motion. But in our day-to-day life, we come across motions where objects cover unequal distances in equal intervals of time. For example, when a car is moving on a crowded street or a person is jogging in a park. Another one example is that suppose in a road the car covers 50 km in the first hour during its journey, but due to some crowd or other obstacles the speed of the car reduces to 30 km per hour in the next hour. The car covers distance of 30 km in the next hour. Again in the third hour it covers 80 km because the road becomes free. So we can see that the distance covered by the car in each interval of time is varying. That is, in the first hour it is 50, then in the second hour it is 30, and then again it becomes 80. So the time interval here is equal, that is 1 hour, but the distance covered are unequal. So this is an example of non-uniform motion. Thus it can be defined as an motion of the object covering unequal distances in equal intervals of time. So this is up to what today. The notes have been prepared and it will be uploaded in the application of our Frontiers Senior Secondary School. So have a look and learn, and I will also assign some home task to you.